All right. Is this on? All right? Yeah, cool. Okay, hey, so I am going to speak to you a little bit about what comes after Federation. So, very quick context, I'm the guy that kind of built it, and it's been a couple years, and as we've seen, it's gotten quite popular and kind of become the standard for the micro distributed deployments. But over time, I've discovered that it might be time for a refresh. So, do we have a general understanding of what Federation does, especially thanks to AWS? Yes? No? All right. The general motivation behind it was we have a lot of complex pieces of an application. Application is usually made up of several teams. Those teams want to normally work independently, either to speed up the velocity or organizational agility of the business, or because the organization itself, typically in the engineering space, is not mature enough to work cohesively together. So either we use it for scale or we use it for premature organizations and we can break them apart and let them work independently. So there are two kind of useful tactics for it. Pretty much we're looking for orchestration, dependency sharing, minimize the UX drawbacks that we would have gotten from yesteryear's micro front ends, and provide as much autonomy as we can. So, you know, we can have a pretty standard looking site. If we're talking front end, you would have something like that. Many teams, many parts, and they can be split and recombined in various ways. Usually what I'm trying to look for is something that's going to be simple or that more or less just works without a lot of cognitive overhead. There were some problems with the ecosystem and why we actually designed and built Federation. A single build has major build performance issues. DLL plugin and externals is too complicated to manage. It is synchronous, so you have to do render blocking, and it also causes a single point of failure. If you do use DLL plugin, you will get stuck in what's kind of a circular redeploy, because you need to share the modules here, and if you want everybody else to have them correctly, it creates a build loop for the whole application, which kind of defeats the purpose. Native ESM is probably the closest thing to, especially with import maps. It's come quite a long way, but it does have quite a lot of network requests, and we do lose some chunking capabilities, especially when we want to try to share modules. So what we kind of need is a scalable trade-off that gives us as much of a compromise as we can without really impacting anything too specific. So that's really where Module Federation kind of comes into the picture. And that's pretty much what it kind of looks like. I think we've gotten the general idea of it. Federation, I think we're familiar with terms here, but we have the consumer, or we have the host application that usually acts as the root Webpack runtime that starts the process off. It imports a bunch of things. We have remotes, which is anything that we're pulling into it. We have the concept of bidirectional hosts and omnidirectional, and those concepts are really combinations of the first two in various different ways. The goals of the technology were to be able to import code from independent builds and deployments at runtime. We needed a way to be able to dynamically share vendor code asynchronously in a way that does not block the application or force us to load more JavaScript than we need to serve the bare minimum of what the user is trying to do. So similar to kind of code splitting, but in our dependency negotiations itself. Deploy independence was a very big part as well. We also want the ability to have versioned or evergreen modules, similar to a lock file that you would have on NPM. Redundancy was quite important as well, and trying to bring a good developer experience, again, without sacrificing our users' experience. So the big things that I really wanted was it to be simple and it to work anywhere that JavaScript can be executed. And that's pretty much what we have now. How it looks to configure, we've kind of seen. Set it up like that. There's a consumer and a remote entry. And the code more or less looks like that. There are several ways that you can actually configure the Federation plugin, but when you're consuming it and using it, for the most part, you just require import code like you would any other time. So there's not really anything you have to learn, no real framework other than understanding what you should share and how, and configuring the plugin. You can get more advanced with the configuration, so this is probably one of the more sophisticated ways that you could use federation. It's quite useful if you need to, if you want control over the glue code. So you need more dynamics, you need to implement A/B tests, you want to detect the environment and change what's happening. You want to QA without needing to have more than one lambda or ephemeral environment. This is where this scenario can come in quite helpful. So that's kind of what we would configure it as, and that's the glue code that sits behind it as an example. It's definitely not the most beautiful or great example, but it gives you an idea of how you can control the interfacing between the two runtimes. So some good places to use it, I think we've covered it. Useful for global components, for feature delivery across teams, horizontal enablement. I've used it a lot for analytics, A/B testing, personalization, across various teams and various parts of the organization. And it has been very useful for systems migration, multi-threaded computing, and of course, micro-frontends. To keep federation stable, since we are now going with at-runtime software distribution and self-formation, there are some rules that you would want to follow to ensure loading code that you depend on at runtime remains stable. If it can change anytime, in any way, without notice, how do you make sure your application stays resilient? So the concept I came up with was component level ownership. The idea is kind of similar to what server components recently came out with, so a lot of shared concepts there. But the idea is we have a smarter component, better co-location, we keep it loosely coupled, and we really enforce ownership boundaries, whatever they might look like. If we took a simple React component that you would see in a monolith, it might look something like that, sending a lot of props to it, a lot of complex data into it, and this introduces fragility into the system because now you are hoping that the shape of your data does not change and that their feature that you're pulling in doesn't crash because the shape of your data changed. Especially if you're refactoring something, this can introduce a lot of risk. So what I usually suggest is we go for something more like that. Pass it the minimal context that it needs, and the component does more of this on its own. It fetches its own data, it will render itself either using suspense or some other kind of paradigm. So that's kind of the general of federation and how to use it. A big thing that has come around, and I think AWS also has something they've been working on called the front-end discovery service. And it's essentially we kind of collaborated on this to build out a schema that was inspired somewhat by Medusa. So this was a project that I built that allowed me to visualize the system and control module federation while it's running in any environment without having to touch the plugin again or try to understand how code bases are used or what's being consumed. So this is kind of what we end up getting when you run a build. It fills Medusa out with all the context. Each one of these is an independent repository, independent system, and you can see what's exposed, consumed, and who's interconnected to who. We can also jump in and see like the node views or something like that, so we can really understand how the dependencies work. And every time a build happens, the system will update, so you can see the application in real time, what it's doing. We also have the dependency tree views so that you can see what version you're currently pinned at. So typically I pin it on the git commit hash, so I can support multiple versions of federated code in the same context of the application for separate parts of it. So I can see who uses what, exactly where it is, and what version, hash, or build it is attached to, and in both directions. So an example of how Medusa would actually work here is I'm going to show you an application where it's a server-side rendered application, so federation works across universally, server and client side. And what we're going to do is we're going to change out the header component, and we're going to do it without deploying any new lambdas, without starting any new builds. We're going to use the current infrastructure that's there, and we're just going to hot swap the code out, just like you would see in the browser when you refresh the browser. We're going to actually perform that universally. So this is what deploying your code looks like on a federated system. So this just shows some of the things that we kind of have there, some details about it, what's shared, all of that. All the deployments that I've got in the list here are previous builds. I go there, it's currently red. You'll see it's still my production URL. And now it's green. That's my deployment. Completely separate build of the application, but no additional Lambda, no infrastructure really backing it that I need to deal with. So that's kind of what we've got. That's where we've gotten to so far with it. And I think we've taken it as far as we can with how I had designed it a couple years ago. And I didn't really anticipate it to be popular. So it wasn't built for everybody to use. And now that there are a lot using it, it's probably time that we adjust it. So in order to adjust it, we also need to understand we need a test case, something big, something at scale. And the whole point of Federation as well was to try to overcome problems of scale. And that is why I joined ByteDance. So ByteDance is one of the largest users of micro frontend and one of the most sophisticated implementations of module federation that I have seen. So it made a lot of sense to go and work there. The level of scale that we have and the problems of scale that we have are, we have 6,500 front ends that we need to manage seamlessly. They will deploy 10,000 times a week, and we have over 5,000 engineers. There is a lot of code sharing across everything from native to web and mobile web, and now moving into the server space as well. So this is very complicated to manage. And when you do have that kind of scale, how are we not imploding under the weight, especially since this company is a hyperscale company? I don't know if any of you have worked in hyperscale companies, but you move quickly and the infrastructure usually is hanging on by a thread after a couple of years. And it becomes very complicated to try and fix that because you're moving faster than your systems can really keep up with. So what are we doing to try and prevent hyperscale issues, and also how are we going to continue to push this to 10,000, 15,000, 20,000 front ends that we can manage more or less in the same time that you saw how I could do Medusa. So a big part of that is our software supply chain. I believe to really make a good development experience, we need to have a strong control over our supply chain and design the system to work exactly the way that we need it to for extremely large scale. So some of the pieces we want is development, delivery, and maintenance. We want to ensure we have alignments, and doing that is very helpful when you have control over a lot of your supply chain. We're able to create really tight integrations, make sure the system is efficient, and all the different parts that make up complex modern infrastructure are designed to work together, but not necessarily be coupled strictly to each other. We also have run into problems when you get to the downstream dependencies. What I will usually say is, we've probably seen this even with micro frontend. You can do a ton of things in the browser, but that's no use if you need server-side rendering. So you're stuck with maybe at best page split verticals. You can split them on the root because you can route them to separate lambdas or separate servers to handle the render. But it's very hard to do that with, say, a single component. You would have to involve more infrastructure like the edge networks and things like that to stitch it back together. You might run into hydration issues, or you have to fall out of kind of the way that I like to do them, where you just import it and use it in JSX, but you might have to fall back into like a multi-mount structure. So really the best you can do depends on the weakest point in your application. So wherever the most rigidity is in your supply chain or your dependency chain, that's the best that you can really do without expensive workarounds. So what does some of our supply chain look like? So we have a couple really interesting technologies here that I'm going to show a few of them to you today. We have Garfish, which is a micro front-end management framework. That's kind of what helps bring everything together. If any of you are familiar with single SPA, it's a very similar kind of concept where we might want to use not the polylithic structure that I prefer, but we want to mount onto specific DOM nodes and we want something a bit more agnostic. Garfish is fantastic for that. We also have RSPack, which is a, we've pretty much taken Webpack and we have rewritten it in Rust, and it is interoperable with your existing Webpack configurations for the most part. There's still a few hooks missing here and there, but the idea is if you're on Webpack, you should be able to switch quite easily to RSPack and you will receive 10 to 20 times bundler speed improvements. We also have a meta framework called Modern.js. We have VMock, WebDoctor, and we also recently acquired Oxidation Compiler. So we now own the parser, the compiler, the meta framework, the management layers. VMOC you can consider very similar to Medusa, but it's ByteDance's internal version. So that's kind of some of our supply chain on how we can control this stuff. We also have most of the RSPack core team here, so thank you for coming down, and great work. But anyway, so getting into a bit about RSPack here. The main concepts were we need something that's fast to start up, good HMR, Webpack compatibility was really needed, mostly because Webpack's API has served very well, and it's been very complicated for really large businesses to work within some of our more modern tools where we might not necessarily have quite as a robust an API. So when the business has very complicated needs, Webpack has generally been what we've had to fall back to, but that comes with a major performance regression, and it's extremely frustrating. Another big challenge that we had found with Webpack was, besides the speed, it was quite complicated. If any of you have configured a Webpack configuration from scratch, it's quite frustrating. You can't start in 5 minutes. You need a bunch of loaders. You need React Refresh. You need things that seem like they should just be built in. So in RSPack, we have tried to bake in most of what you need, so you can just start with it, put an entry point, and if you want to extend it, if you want all the power and configuration that Webpack has, you can add it, but you don't necessarily need it for everything because we have a lot built into it already. And it's framework agnostic, of course. I would say the big one is really the speed here, especially if you come from Webpack. There is a drastic speed improvement, and this, I believe, is a benchmark of 50,000 modules. So that's a 50,000 file application build, and we can do it in about 3 to 4 seconds. To show you an actual demonstration here, this is me compiling 3 sub-applications, and that was it. So for me to build 3 separate meta framework apps, it takes about 400 milliseconds. So that's kind of the speed you're looking at to do end-to-end build, and you're done. Moving on to the next kind of piece from RSPack, we have our Modern.js or EdenX framework. EdenX is the next generation of Modern.js. Modern.js is our open source current stack. The idea behind Modern.js really was we have a meta framework. We also have something to generate documentation and handle things like DocuSource would. We also have module engineering practices, so deploying, publishing NPM packages is quite tricky. And it would be kind of nice if we were able to fold several of these aspects into a more cohesive environment for general web development. The idea between a lot of these things is that they are not coupled. So if you see something useful, you can use just that, and you don't really need to buy into a big ecosystem or any parts of it. Tightly integrated, but as loosely coupled as we can make it work, while offering a good experience is the ultimate goal of especially EdenX, our next generation. We also have the builder aspect of it, so if you don't want any of our framework stuff or any of that, but you really don't want to deal with complicated configurations, we also have the builder part there, and you could just use that as the build system for any custom meta frameworks that you've got. If we move into VMOC, we have something very similar to Medusa, but it's our internal version, and this is what allows us to change and manage the thousands of applications on the fly very quickly and very seamlessly. To get something out and deployed, what it would look like is this. I would go into our source control manager, I would publish a new version, it would pop a version out for me. What it would look like when we're delivering is something kind of like that. You know, sorry for the translation, I can't read it either, but the screenshot really articulated the point well. The idea is there's the building process, how we deliver it, goes through review, goes through our deploy layer, merge request, and out and into storage. And then on the other side, what you can kind of see is the parallel delivery tracks that we've got. Every team can deliver with their own independent pieces, and it can all flow out without blocking anybody else. One of the things that we have seen in Federation that's been quite challenging is it's very hard to debug and understand what is it doing. So something that ByteDance has solved quite nicely is they've added a very robust layer of information that we've been able to build Chrome DevTools off of and other extensions to bring controlling these applications directly into your browser in an intuitive way. You can also just debug it, and it'll flush out all the information available. So now you can see who's using what it's pinned to, where it's at, all the information that's usually hidden inside of the Webpack graph that's very hard to get to. It's now easily available. And I believe there's also a plugin system as well, so we have a life cycle in there, when a remote loads, maybe when it fails, so on and so forth, and that's an area we want to continue to extend. This is kind of what our Chrome extension looks like for VMOC. So In here, I can go in and change it, and I can see who's connected, what the graph looks like, very similar to Medusa, and I can swap out versions anywhere that I want, however I want, and I can debug and inspect it and so on. So this is quite helpful to have built right into your browser. Imagine having this in production, where you have a production bug, and you could go and debug production by rerouting a specific module just to test this out locally, right from your Chrome DevTools, and redeploy it, potentially in the future, directly from your Chrome DevTools as well. So one other big piece of this is WebDoctor. So this is something new that we've been working on, and I found it quite nice. If anybody's worked with builds and bundles, it's very hard to understand where does performance problems come from, where do they occur. Why is the application getting slower? What can I do about it? It's not easy to really understand that. We have Bundle Analyzer, but usually that's not been very helpful. And any of the other tools that are out there either don't work with Webpack anymore, or they are terrible to use. So WebDoctor tries to take a lot of the good ideas that we've had out there and bring it together in a cohesive experience. So we have general things about our build warnings, what's going on, tags about information, how it was built, sizes of various things, try and give the developer more understanding of what's going on, hints, ways to debug application performance and the bundler specifically. You can also see the entire file structure, how much everything is, what's used, what's not used. Inside of there, we have also got tree shaking analysis, so we can actually show you exactly what was not tree shaken and what was tree shaken across your build. So you can see even the code directly in there. You can see exactly how things are working and what's there and what shouldn't be there. Another big challenge we've seen is in the build time space, especially for Webpack. It's very hard to know why things are slow. So including the telemetry to actually know how every plugin is impacting your overall build speeds will help you diagnose why something is slow and try to get some more performance out of it. While a lot of this is showing you Webpack things, it also works for RSPack because the two compilers are interoperable with each other. So whatever works with Webpack should work with RSPack as long as we've got the hooks out. Still a relatively new project, but it's going well. So in here we also get some more information just about resolving time. Again, more speed. A lot of people don't know, but the module resolution process actually is quite expensive. And it's difficult to understand exactly where, why, or what. So this shows you how long every single component, every import took to resolve everywhere. And then the last part of WebDoctor is we actually can profile the build, and we can see how long every loader, every hook takes for every file that you've got. So now you have a full, very comprehensive view into exactly what's going on inside of your application, what's slowing it down, and you can think about how that could be processed differently, so on and so forth. So with some of this stuff here, I kind of want to talk about what would come next. So we already have federation, which allows us to have at runtime self-formation of our software. We have seen that we've got some very cool tools here. We have the ability to understand performance a whole lot better. And if we start to integrate these things together into a single cohesive experience for developers, what could that start to look like? So combining it, first step, if we start creating feedback loops between these things, imagine WebDoctor detects bad tree shaking or a performance issue, and if we pass the feedback loop into VMock or Medusa, VMock is our internal one, and Medusa is a software as a service, so you can just go to medusa.codes if you want to check it out. But the idea is we create a tight feedback loop here. So if we see something isn't right, we would be able to instruct the system to change how it operates to try and fix the problem. If there's a performance regression, we could automatically pin this to the previous deployment as long as we know that the deployment still keeps the system stable, offering ways to bring more self-healing into the application. Another big thing I think we could do is when you share software, you would maybe treat it as an external, or in federation, we'd do something similar. A problem with sharing code is it's a double-edged sword. When I share a module, I turn off all the tree shaking because I don't know how it's used by other applications. But in WebDoctor, we can see how every single export is used across every application that's there. So if WebDoctor's data goes into something like VMock or Medusa, we can then instruct federation on exactly what's used where, and we can tree shake across builds and still share code in a reliable manner, or come up with certain strategies to optimize it, and if there's certain exports or weird deviation, we could go and fetch additional exports without breaking the system, but still keeping it very optimized. So a big piece of what we would like to do with the whole direction of everything is try and really meet users where they're at. A lot of ecosystems really try to lock you in quite tightly, and I think that's a big disadvantage to business capabilities and so on. It also creates a very high barrier to entry for anybody who wants to migrate onto newer technologies. If you have to have an all or none solution here, you lose out on a lot of capabilities. So what we would like to do is, how much of our tools can we offer in a take it or leave it style? You don't need to use everything, use what you want, don't use what you want, hopefully you like it, no lock-in, no gotcha. One piece we'd also like to do here with this kind of thing is, since we do own our own meta framework, we would like to integrate the server-side federation alongside our client-side federation tightly into it, so that we've got a really cohesive system that's designed for distributed systems at a very large scale. I also think it's time to redesign Federation. So either improving its hot reloading or at least introducing live reload natively in there would be great. Built-in support for TypeScript types, kind of offering remote types to help provide a bit more easier validation when working with these things. Adding life cycles like middleware in between the module and the runtime so that you can adjust things on the fly, personalize it, try different experiments, anything that you want. A big area I want to improve on is the resilience of it, because Federation is at runtime, so what happens if something goes wrong? Usually we wrap them in an error boundary or a try-catch or something like that to keep the system running. But if there's, but that still puts it on the developer's responsibility to make sure the system remains stable. So what we would like to do is actually bake in several capabilities, such as when you pull federated modules during the build, we will back them up into your build since we don't need to recompile them. It doesn't take up any extra overhead, but we can pull them down, store them in your local graph, and if for some reason the online container is not available, you could switch back to the one that was last pulled inside of your build. Same thing to offer for NPM as well, and then having those capabilities would also let us push this out to edge workers where we can't, certain edge workers like Cloudflare can't support Federation right now. But if we have all this built in, we can offer several different ways to go off and get it. A big one as well would be better dev tools just built into it. And I would love to see if there's better interfaces for supporting configuring your actual plugin and what it's all doing, but configuring it not through the build. So if you want to change or expose a module or change how something is shared, imagine being able to do that through something like Medusa, and you hit save, RSPack fires up, it takes 200 milliseconds to compile your application, and you're back up and done practically in the time that it takes you to tab between windows. But that could be your production build. So these are some of the ideas that we're kind of looking at. When we get into the meta framework area, I think some of the spaces we would like to improve on is root aggregation. This is always a complicated thing. How do you bring applications rooters together without re-centralizing the root structure? So something to aggregate our roots I think would be really helpful. Offering CLIs, things like WebDoctor, profiling, logging, RUM data collection hooks built into the framework itself. So really anything that you kind of would want to do in a large-scale distributed system is available, and you don't need to use it if you don't want to. Keep it simple, but you can tap into more power anytime that you would like. So kind of on this, a thing that I think would be great is this concept of infrastructureless. So if we understand Federation kind of, it allows us to pull code in at runtime anywhere. So if we have that in place, we don't really need a ton of backing server infrastructure. As we know, when you get servers involved, it becomes very complicated to manage and network everything everywhere. So if you have something like Federation, we've essentially decoupled the file system from the compute primitive. That means every Lambda connected to your network is effectively just a worker, and you can send an instruction set to it on the fly, and the nearest Lambda available will become any code base connected to your system on demand. If we have a policy in there to say it's not allowed to do certain things for compliance, then it won't do that. But if you don't put any rules around it, it'll essentially find the warmest, most available concurrency that it's got, and it will become any service, any piece of your software, any piece of your company's stack on demand with little to no overhead. Companies where I've worked on this before, we actually only had really 2 lambdas in the entire company, production and non-production. Every pull request, literally everything happened on the non-production, and it was a single lambda. If you need to test things in parallel, all that would happen was the concurrency would rise. But there was no backing infrastructure beyond 2 lambdas and I think a little JSON file. And that was pretty much our whole infrastructure. So getting less frequent deploys, offering similar concepts like bundle dropping into your infrastructure could really ease up the burden. It allows us as front-end developers or JavaScript developers to really not have to learn such a broad part of the stack just to get something that I feel is really simple, like scripts out the door. I really miss the jQuery days where it was all simple. So kind of going into this, we have things like fractal architecture. So if we build out Federation, it's already fractal. Each piece can kind of sustain itself, and it's all self-forming, and we're not depending on a single orchestrator to bring the system up for us. But since it's fractal, that also allows us to do other scenarios, like create very strong redundancy layers and dynamic load balancing and optimization across the whole system, handing off workloads to somewhere else. A good way I like to think about this is if anybody's aware of Schrodinger's cat, the cat's like alive and dead at the same time until you go and check. But that's how I kind of see Federation, where the execution path for your code is defined when the request happens. Until the request happens, your entire infrastructure is in superposition. Every Lambda, every server available is anything and nothing. And only when a request hits your infrastructure will it collapse onto a wave of possibility, perform an execution, and as soon as the reply comes back out, it will break back into the superposition again, ready to become anything, anywhere, at any time. So building on that, we could, if we take Fractal and this concept of infrastructureless, we could get into compute resources as shared dependency. So this is kind of a new idea that I'm thinking about doing, but what if we took, similar to how Rust does bindings, where you have JavaScript and you have Rust, and to communicate across them, it creates a binding in between the 2 layers. What if we did that inside of the module graph for every import, for every function you did? So now the runtime would have the ability to determine, should it execute it on the thread? Should it send the call stack to another worker? Should it send the call stack to the edge? Should it send it to node? And then once you're in node, because it's fractal, the code base can continue to do that. So now you have self-distributing, self-balancing workloads where the runtime itself will decide the fastest and most reliable execution path for the client to receive a good experience. We as developers don't have to think about how we're really going to design it. Import the code, let the runtime understand the best conditions for the environment that it's running in, and it will adjust to give the user the optimal experience. Okay, almost done, sorry. So pretty much that's kind of what we want to do with it. These are some of the ideas we're thinking about. It might look really crazy and very complicated, but it's not as complicated as it sounds, but it's not as easy either. So how do we bring this really back to out of ByteDance? Because this is what we would like to do, but how does that benefit the user base? Why would you care what we're going to do? Well, I believe that would be because I'm actually announcing here that we are going to unify my ecosystem, which is all of the Federation stuff, everything that I've ever written in the past 3 years, and whatever ByteDance has been working on, we're going to unify our ecosystems. So whatever we have, the idea is that you will have it. Our node federation that I've released, we're going to rewrite it, implement it with a lot of these tools, a lot of these capabilities, and as our other pieces of technology become available outside of the company, you should be able to get the benefits of that. But immediately, anything that I own, we're going to begin the unification process of, to give you something that is tested at scale, stable, and is infused with the resources of a big tech company. So thank you so much, and there we go.